All right, Algebra 1, we are starting chapter 4 with 4.1. We have systems of equations. So a system of equation is just a pair of equations that go together. Sometimes they have the same solution, sometimes they have no solution, and sometimes they have infinite solution, kind of depending on the lines. So here in our first example, we have the question, is the point 3, -2 a solution to this system? And then later we'll get onto this system. So we have an x value and a y value in our point. And we have two different equations. So let's just take a look at the first one right down here. We have 3x plus 3y equals 3. Hopefully it's 3. So we want to know if this point is a solution to this equation right here. So we're going to take the x value and plug it in for the x right here, and then take the y value and plug it in for the y's right here. So it's actually 3 times x plus 3 times y equals, and when we plug it in, 3 times 3 is 9, and then a positive times a negative is a negative. 3 times 2 is 6, so we have 9 minus 6 is 3. Does this number match up with our answer up here? You betcha, good to go. Now we got to check the second equation. So we have 4x equals -8. Notice we only have an x value, not a y value, so we're only going to plug in the x to this x. So instead of 4x, we have 4 times 3, and 4 times 3 equals 12. So does this 12 match up with this -8? Absolutely not. So this does not count. Both of these have to be true for it to be a solution. This is not the case. We have a true right here and a false right here, so this is not a solution. So it has to satisfy both equations. It has to work for both equations. Now over here we have 3x minus y equals 11, and x plus 3y equals -3. Again, we're going to take the x and the y. We're going to plug them in for the x and the y. So 3 times 3 minus a -2. 3 times 3 is 9. A negative times a negative is a positive, and we just have 2, right? So 9 plus 2 is 11. That checks out with that. Moving on to the second equation down here. We have x plus 3y equals something. Our x is 3 plus 3 times -2. So we have 3, a positive times negative is a negative. 3 times 2 is 6. 3 minus 6 is -3. This -3 matches up with this -3. Both of these check out. So yes, 3 -2 would be a solution to this system. A different way to solve a system of equations is by graphing the two lines. So if we have this system right here, we have the equations 4x plus y equals 6 and -x plus 2y equals 3. Let's take a look at the first equation right here. It's really hard to graph this right now. I prefer to graph, and we prefer to graph in the y equals mx plus b form. So let's get y by itself. So down here, we're going to get y by itself. We have a positive 4x. Let's move it over by subtracting it to both sides. Now we have y equals -4x plus 6. We can graph something like this. So we're going to go to the y-intercept at 6, down 4, right 1, down 4, right 1, down 4, right 1. There is our line. For our second equation, we have -x plus 2y equals 3. Let's get x or y by itself again. We want to get y equals mx plus b. How do we move a -x to the other side? We have to add it. We got to do the other sign. So now we have this 2y left over equals positive x plus 3. Still need y by itself, 2 times y, so let's divide by 2. And if we divide one thing by 2, we got to divide everything by 2. These are going to cancel and y is by itself. X divided by 2, same thing as 1/2 x, because there's that imaginary 1 in front of the variable. So 1 over 2 times x, 1/2 x, plus 3 over 2, that's 1/2. So here's our y-intercept at 1/2, kind of right between the 1 and the 2. And our slope is up 1 and over 2, up 1 and over 2. And notice these two lines, if we look on Savas, it'll be a little nicer than my drawing, but they intersect at the line 1, 2. So the solution to this equation is the point 1, 2. If you plugged in a 1 for the x and a 2 for the y, you'd be good to go.